Hey, grade 10. So we're now on lesson 2 of Unit 8, looking at the future value of compound interest. And again, you're probably wondering, a great question would be, what do I mean by future value? We won't actually directly talk about that yet. It will make a bit more sense when we look at lesson 3. So lesson 2 and lesson 3 are kind of joined together, but still a little bit separate. That's why I decided to just keep them separated there. So our learning objective is to basically distinguish between simple and compound interest, which I kind of referenced compound interest, but I didn't really go over looking at the differences between them. And then we're just going to look at some examples of how to calculate a compound interest of an amount. So the first thing is understanding what compound interest actually means. So compound interest, we actually can see a little bit of a connection between this and we can actually see a bit of a connection between this unit and exponential functions unit. So we learned exponential functions that if we have if we have an exponential growth, and let's say it's increasing by a certain percent, you might actually recall that if something was increasing by, let's say that there was an increase by R percent, right? So what I asked you to do is basically add 1 plus R. That would be the total increase rate that we have there. And again, the reason for that was because we are not only adding on the initial amount, you're adding on the percent, the amount that we increased by. So we would take our initial amount, our initial population, and again, there were different formulas for this, but this is one of them that we use, initial population, or we also use the A parameter as well, same idea, and we multiply it by 1 plus by the rate of increase. So this was the rate of increase, and we raised it to the power of n, which is basically how many compounding periods we had. So we're kind of using the same idea here, except that with it, because in an investment, really, what we're doing with compound interest is our amount that's in our account is actually increasing multiplicatively by the same rate over and over again. The only difference is that now we look at rates in terms of, from a financial perspective versus just looking at, although we did actually look at some financial examples, but it's a very similar concept to this. We're essentially just saying take the initial amount and multiply by 1 plus the interest, or sorry, I keep saying interest, 1 plus the rate of increase, and then raise it to the power of how many compounding periods there are. So again, very similar concept, but just seen in a different way. But I want you to kind of see that this formula that we have for compound interest is actually extremely similar to what you saw in exponential functions. There's just a bit of a subtle difference in terms of the terminology we use. So let's just start with an easy example. Let's say that you have $500, and you're told that it grows by 2% each year. So how much would it be worth after 4 years? And to be clear, it grows by 2% every single year. And again, we're not talking about compound interest yet. I don't want to actually bring up that word. But let's say that we specifically are told that every single year, you're going to take the amount that you have and you're just going to multiply by 0.02 every single year. So that means that after the first year, I'll just do an easy example here. After the first year, we have $500, and we're going to multiply this by 0.02. And then what we do, this is going to tell us, the interest rate that we've earned. This is the interest that we've earned. And then we're going to add that to the principal amount. And again, we know that the total amount that you have is the interest amount plus the principal. So the principal that we have here is going to be $500. And again, I know this looks a little bit messy. Let me just fix this up a little bit. And again, this is one way to do it. And to be honest with you, this isn't the easiest way. I just want to show you kind of one way that we could do this. So we take the $500 plus 0.02, and then we add on the principal amount, which is basically what we invested initially. So how much do we have altogether? Well, 0.02 times 500 is 10. So we have 10 plus $500. That means we have $510 in our account after the first year. So what's going to happen now is we're going to take the amount that we have in our account, and we're going to say, you know what? I'm not going to, in the other example, when we looked at simple interest, we would basically take the interest amount that we've earned, which was $10, and keep adding it over and over again. So we would have $520 after 2 years, $530 after 3 years, $540 after 4 years, and so on. That's not the case here. What I'm asking you to do is actually is to find 2%, is to find out what 2% of each after each year is, and then add that on to the previous amount. So what I'm going to do now is I'm going to take this previous amount that I had here, and I'm going to find out what 2% of this previous amount, $510, is. And then I'm going to add that to the $510 that I had previously. Because now I don't just have $500 in my account, I now have $510. Doesn't seem like a big difference. And you're probably wondering, well, like, why does it even make the difference? Let me just tell you one thing. Rounding is extremely important in financial math. You can't just say, it looks close enough. It is still a different answer, right? Every penny counts, because every little penny goes a long way here. So what we're going to figure out is what 2% of $510 is. So what's 2% of $510? Well, 2% of $510 is, again, grab a calculator to check this. And I know I have my answer there, but I just want to make sure I'm actually correct. I'm not making a mistake myself. 0.02 times $510 is $10.20, and then you add $10.20 to $510. That means you have $520.20 altogether. So again, compare this to what it should have been, which was $520. It doesn't seem like a big difference, but it still does make a difference. Even after 2 years, you already, and again, this is a very small amount, by the way. $500 is a very small amount you're investing. So there's no shocker that, you're not going to be earning that much. But if this was, instead of 500, it was 500,000 or 5 million, you can see that it makes an even bigger difference now, right? So what I'm going to do now is I'm actually going to find out how much I have after the 3rd year. So after the 3rd year, I'm going to have A is equal to $500. Sorry, not $500, $520 and 20 cents. And I'm going to multiply that by 0.02. And I'm going to add $520.20. Again, there's an easier way of doing this, and I believe we discussed this already. You could obviously factor out the $520.20, and then that basically leaves you with 1.02, right? You end up with 1.02. And this is kind of an easier way to get to the direct answer, right? So we could take the previous amount, and instead of me finding out what 0.02 is, and then multiplying by, finding out what 0.02 times $520.20 is, so 2% of $520.20, and then adding that to $520.20, you could simply just multiply $520.20 by 1.02, right? And this is, again, coming from our equation up here, right? We learned in exponential functions that instead of me, multiplying by the amount that it's increasing by, and then adding that to the initial amount, I can just multiply by 1 plus the rate of increase, right? And that's essentially what I'm doing here. I'm just taking my previous amount and multiplying by 1.02. And so when I do that, let me just do the math here. $520.20 multiplied by 1.02. I end up with, and again, this is $530, and I always want to round to 2 decimal places because money has 2 decimal places, right? So we have pennies, so it's going to be 61 cents. Sorry, 60 cents, actually, if I round down. So again, be really careful with this. You want to always, one thing that's really important is whenever you have, in anything with financial math, unless I tell you otherwise, you are always going to round to 2 decimal places, right? We always assume that we include pennies as well. Okay, so now that I have that total amount there, $530.60. This is the amount that's how much I earned after the 3rd year. And of course, I'm not going to continue this on because this is very time consuming. And I think you kind of see what we have to do here. What we're going to do next, and I'll erase this so it's more clear. To find out how much you have after the 4th year, you would take the amount after the 3rd year, which was 500 and oh geez, I totally forget. I erased it too quickly there. I think we said it was 500, and let me just do that really quickly. Times 1.02, $530. Let me just erase that. $530.60, right? So then we take that amount and multiply by 1.02, And then this gives me the amount that I have after the 4th year. I'll let you figure that out. Now, we're getting pretty close to this, but we obviously want to find out how much is after 5 years. This is a very time-consuming process. And if you're looking at this and you're like, that takes way too long, you're not alone, because I'm feeling the same way. This is taking way too long. So is there an easier way to do this? Well, I kind of noticed that to get to the next year's amount, so when we went from $500 to $510 to then $520.20, what I really was doing each time was multiplying by 1.02 every single time. So what I notice here is that there's actually an easier way for me to get to the answer directly. I can actually use that formula we discussed. You can simply take the $500 that you initially had, that you initially deposited, and you multiply by 1 plus the interest rate. So it's very similar to this formula here, right? Again, the only difference is that the rate of increase is the interest rate now. The initial population, which we discussed before, initial amount, is now the initial deposit that you had. So this of the $500 is then multiplied by 1.02, and then we raise it to the power of 5. And why do we raise it to the power of 5? Because there are 5 compounding periods. And then this gives me my more direct answer, which didn't require me to do multiple steps. I could just get straight to the answer. So notice how much quicker that answer was. So what I notice here in general is that I can just take my initial investment that I deposit, my principal amount, I multiply by 1 plus the interest rate and as a decimal, and I raise it to the power of how many years I invested for. So my general formula is A plus, the A, which is the future amount or the balance in my investment. That's basically how much money do I have in my account, is the principal amount plus the interest rate. The principal amount times 1 plus the interest rate. And again, the reason why we're adding 1 to the interest rate, we already kind of discussed this, because you are not only adding the principal amount, you're also adding that interest. So you are basically multiplying the principal amount by itself, and then you're adding on the interest rate there. So it's 1 plus the interest rate. And again, this is just coming from the exponential formula, which tells us that P at n is equal to P naught times 1 plus R to the power of n, right? Same formula as before. And then I'm raising it to the power of n, which is a number of periods that I have, or a number, like basically a number of compounding periods. We'll talk a little bit more what I mean by period, but for now, we assume it's going to be years, but later on, it's not always going to be years, right? And then, of course, the I that is represented here, the big I, simply represents how much interest was earned. So if I want to calculate the interest that was earned, all I need to do is simply take the total amount that I have in my account, and I subtract off what I initially put into my account. So that's what interest really is looking at, is how much extra money did I have to pay for either borrowing that money, or how much money how much extra money did I earn by lending that money. So it's basically a little extra amount that you got, right? So we simply take the balance in your account and you subtract off how much you initially put into the account. And again, the principal just represents your initial deposit, right? It's the same as before. So the good thing is some of these words, or some of these symbols, are pretty much the same as what we saw already with simple interest. But notice that for compounding interest, it's customary to use I, not R. Okay. Don't ask me why, it's just how it is. And then for a number of periods, instead of using T, we use N, right? So there's a couple little differences there. So compounding interest, in the other examples, and the first one that we kind of looked at, that was assuming that we had an annual interest rate, right? So it's 2%, and then we were basically compounding every single year. What if it's not compounded every year? And actually, it's not very common that you're just going to have an annual interest rate. It's actually more common that you would have different compounding periods. So if it's not compounded annually, you have to kind of consider that your interest rate, your I%, and the N amount that we have here is actually going to change itself. So the actual interest rate, the periodic interest rate that you have, and the number of periods that you have will actually change depending on how often your interest is compounded. So what I mean by how frequently your interest is compounded is basically how many times you get paid the interest. And again, this should kind of make a little bit of sense here. If you, for example, let's look at the first example here, because compounded semi-annually. Semi-annually means you get paid twice a year. So going back to the example, if I got paid 2% per year, I hope everyone can kind of see it wouldn't really be fair for if if it's increasing by 2% per year for me to pay someone. So one person gets paid, just 2% and that's it, and then the other person gets paid 2% in June and then gets paid 2% again in December, right? Because that would actually mean that they got more than twice as much, right? So it doesn't really make sense. Actually, it's more than twice as much, but I don't want to go into that detail there. But we can definitely see that they're not equal to each other, right? So to be fair with this, what the banks will do is they'll say, you know what, since we're paying you twice a year, then every time that we pay you, we're only going to pay you with half of the interest rate. So instead of paying you 2% twice a year, they're going to pay you, sorry, instead of paying you 2% once a year, right? They're going to pay you 1% twice a year, right? So they kind of split that up. And then, and again, this actually is to your benefit. It's actually not equal to each other. You would think it's equal, but and again, we'll maybe look at some examples of different compounding periods. But the more you compound your interest, the more you will actually earn, right? So it depends. I was going to say it's good or bad depending on which person you are. If you're the person that is borrowing money, that's a bad thing, because if it's compounded more, that means that you're actually going to be paying more. But it's a good thing if you are the person who's earning that interest rate, because that means you're going to get paid more frequently, which means that ultimately it's not actually equal. You're going to get a little bit more, right? It's not a huge difference, but it still makes a difference overall, right? And again, it depends on how much you invest, but every little difference goes a long way, right? So I hope you kind of understand this. So what we're doing is we're basically saying the interest rate here that we initially had in our formula is actually going to be divided by 2. And again, the reason we divide by 2 is because it's compounded twice a year. So that means that interest that I used to have has to be split into two different, it's split into, right? Because I'm getting paid twice in the year. In terms of how many periods you have, though, we actually notice that it's the opposite effect. It's going to be multiplied by 2. And again, that makes sense, because if I tell you, you get paid twice a year, and let's say that you get paid, you invest your amount for 4 years, right? And so you're getting interest twice a year. So interest twice a year. So doing the math here, that means that it would be 4 times 2, right? I simply take the number of times that it gets compounded per year and then multiply by how many years I have. So notice that this is affecting the annual periods. So the number of annual periods that I have, right? Sorry, this is the effect that it has on the initial n that I had, right? For the n representing that number of annual periods. So if I want to figure out how many compounding periods I have now, it's going to be twice as many, right? For quarterly means that you actually get paid 4 times a year. And again, you can always keep this table. You don't have to memorize this, but I hope you understand this. Some of these words are a little bit new. Obviously, you know what monthly, weekly, and daily means, but quarterly is one that you may not have seen before. Quarterly means you get paid 4 times a year. So if you get paid 4 times a year, so an example, this would be, or you have to pay 4 times a year. Example, this would be like property tax or something like that. That means you're going to take your interest amount, which is I, and you're going to divide by 4. And again, you divide by 4, again, same reasoning as before. If I pay you 2% for the whole entire year, but I'm paying you 4 times, it makes sense that I'm not going to pay you 2% for the 4 times a year. I'm going to pay you 0.5% each time. So it's going to be 0.5% each time. And then that means that it's a total of 2% for the whole entire year. Okay. So I simply take the interest rate divided by 4. And of course, the effect that it has on the number of compounding periods, I simply take the number of years that I have and I multiply by 4. Monthly means that I'm going to get paid 12 times a year. So again, it makes sense that if you get paid 12 times a year, you're not going to get all 12. You're not going to get the same percent interest rate 12 times. You're only going to get it. You're going to take that interest amount and divide by 12 because you have to spread it out evenly, but you're going to get paid 12 times a year. So if I invest, for example, for 4 years, it's going to be 12 times 4, which is 48. Semi-monthly means I get paid 24 times a year, and I think you kind of see this pattern here. I'll let you kind of do the rest of this. I think you can see what happens here. Semi-monthly or bi-monthly, so it kind of goes by both two names, and this is what makes this one tricky. Normally for semi-monthly or bi-monthly, I will even emphasize what I mean by that. It basically means you get paid twice, 2 times a month. That's what that means. You get paid 2 times a month. So if you get paid 2 times a month, doing a little bit of math here, there's 12 months in the year. So 2 times a month, that is 24 times a year, right? So I take the interest rate and divide by 24. And of course, the fact that it has on the annual interest rate is to just take the number of years and multiply by 24. Weekly means I compound it 52 times. And again, it's 52 times because there's 52 weeks in a year. And I simply take the interest rate and divide by 52. And then, of course, the effect that it has on the annual rate is that I take the n and multiply by 52. And daily obviously means 365. It's compounded 365 times in a year, which means that I take my interest rate divided by 365. And the effect that it has on the annual rate is just 2 multiplied by 365 altogether by the number of years. So I hope that kind of makes sense so far. Again, these are just the most common types of compounding periods that you could have. Now, one thing to really watch out for, be really careful with this, and I totally get the confusion here, is that sometimes people will look at a question and and actually this is actually going to come up on your test, so I can warn you about this. You'll have a scenario where it's like, you do the math and you say, oh, it's invested for 18 months. So sometimes what people will do is it depends on what the question is asking. So there's sometimes a little bit of confusion because you could look at 18 months and say, let's say it's compounded weekly. Then you might get a little bit lost because you're going to be like, wait a minute. So there's 4 weeks in a month, right? And I hope I'm not confusing you here. 4 weeks in a month, and then you can multiply that by 18. And that would mean that 4 times 18, there are a total of 72 weeks in this 18-month period. So there's 72 weekly periods. However, 18 months is also the same as 1.5 years, right? So this is where some students sometimes get confused because they're like, there's 2 different answers depending on what it is. I'll make it a little bit easier for you on the test. I will make it pretty clear which of these formulas you're going to use, right? So if it's 1.5 years, you're going to get a different answer if you look at that monthly if you look at that weekly, because we know that there's 52 weeks in a year. So I can take 1.5 and I multiply by 52. That means that there's actually 78 weeks if I want to be more specific. So to find the number of weeks, I take 1.5 and I multiply by 52 because there's 52 weeks in a year and I get 78 weeks. So notice that I actually get a different answer depending on which method I use for this, right? But generally speaking, as a general rule here, I will try my best to make it clear as to which one you're looking for. On the test, instead of giving you the time, I'm actually going to tell you, I'm going to tell you the dates. So again, you're going to have to do a little bit of calendar math. I call it calendar math because you're going to have to figure out how many days there are in between the dates given. But I'm hoping it will still be relatively easy for you to figure out, right? Again, if you remember these definitions, then you're golden, okay? Just know exactly what they mean, right? So quarterly, again, means that you compound 4 times a year. Monthly means you compound 12 times a year because there's 12 months in a year. Weekly means you compound 52 times in a year. So if you remember that, you're good to go. Okay, so let's look at an example here, comparing simple and compound interest. So we have 2 different investment options. We have Tim's bond, which pays 5% per year in simple interest, and then Judy's bond, which pays 5% per year compounded quarterly. So we need to figure out how much, which one is better here. So who ends up with more money at the end of the investment and by how much? Well, in Tim's bond, it should be hopefully easy for you to kind of figure this out. We know that the P amount is going to be $1,000. The interest rate in this case is going to be R for simple interest is 0.05, and the time is 5 years, right? Because we invested for a total of 5 years. So that means I end up with $250. Let's compare that we end up with $250 in interest, which means the total amount we get is $1,250. Let's compare that with Judy's bond. So in Judy's bond, it's a little bit different. We need to take the 5%, but we're told it's compounded quarterly. So what we're going to do is we're going to take the interest rate that was given to us and we're going to divide it by 4. So the interest rate given to us was 5%. So we are simply going to take 0.05 and we're going to divide that by 4. And then we're adding that to 1, raising it to the power of 20. Now, why are we raising it to the power of 20? Didn't they tell us that it's 5 years? Well, again, this is where you have to use the math, the table that we just learned. So we're told that it's compounded quarterly, which means that in every single year, we actually compound it 4 times. So that means that the total number of periods I have is 5 years times 4, and that is the total of 20 compounding periods. So that means that I'm actually, I'm calculating the interest, I'm compounding the interest 20 times. So I'm going to take 1 plus 0.05 divided by 4, and I divided by 4 because, again, it's quarterly, so I have to divide by the 4 compounding periods there, and I raise that to the power of 20 and then multiply by 1,000. Again, this is just a matter of you being really careful with your math. Don't forget about bad math. I feel like sometimes students forget that. So you grab a calculator, and I'll show you the calculator steps here. So I take 0.05, I divide by 4, I add 1, and then I'm going to raise this to the power of 20. Now, on your calculator, and this, you do not want to have to multiply this 20 times. You can definitely do something wrong. So you're going to be looking for a button that looks like this, x to the power of y. So it has x to the power of y there. Look for that button. You're going to press on that, and then you're going to press 20. Now, again, your calculator could be slightly different, but this is how I'm inputting mine. I raise it to the power of 20, and then I simply take that answer. And again, don't delete that answer. I wouldn't even bother writing it. Just take that answer and then multiply by 1,000. And you end up getting $1,282 and 0.372, blah, blah, blah. Now, remember before I always specified, I had to specify how many decimals I round to. I don't have to do that in this case because for money, I always assume that it is rounded to 2 decimal places. So to round to 2 decimal places, I look at the third decimal place, which is 7. And because that is greater than 5 or greater than or equal to 5, well, it's definitely greater than 5. So then we round it up to 0.4. So it's going to be $1,282.04. So to find out how much money you got, how much extra money you got, let's compare the two amounts. So again, for the first one, by the way, the interest, when we use the interest formula, that only tells us how much interest we earned. So this is only interest earned, but it doesn't tell us how much money we have altogether. So to find out the money, the total amount you have altogether, you add that to the initial amount that you deposited, which is $1,000. So now what I'm going to do is I'm going to look at the $1,250. I'm going to compare that with the $1,282.04, and I'm going to figure out how much more money did I end up earning. So I ended up earning $32.04 extra, right? So if you look at the difference, I ended up earning $32.04 more by putting it in compound interest, right? So same amount of time, but you can clearly see that with compound interest, you ended up earning a little bit more. So it does make a difference, right? So one thing that we noticed so far is that with compound interest, with simple interest, we were actually earning the exact same amount every single time. But in compound interest, we actually earn more and more interest as we go along. And that makes sense because we're basically accruing more money. So the word accruing, I don't know if you ever heard that word, basically means that we're just accumulating more, right? So because we're accumulating more money, then obviously the amount of interest that we earn and the total amount that we earn altogether is increasing the whole entire way. So in simple interest, it's kind of constant, right? You're just increasing. The total amount in your account is increasing by the same amount every single time. Whereas in compound interest, it's accumulating exponentially, right? We're increasing by a certain ratio, multiplicative ratio, the whole entire way, right? So it's an example of exponential growth. So compound interest, just so you know, is a lot more common nowadays. So this is the one that we're going to look at the most now. Not that simple interest isn't important, and it still is on your test. And there will be a few questions on it, but most of the tests will be focused on compound interest. So let's look at another example here. This is a good realistic example. So Joe has a credit card and he gets a bill. It's $2,500. Yikes, that's a lot of money, right? It's compounded daily, which means that he has to pay interest. Sorry, he doesn't have to pay interest every day. That's not what it means. What it means is that the interest calculated, it happens every single day. They automatically are counting the interest every single day, right? So it's compounded every single day there. So that's quite a bit. So he's not able to pay the bill until 12 weeks after the due date. So he ended up waiting a little too long. And now he has to pay 12 weeks after the grace period of the due date. So what's the amount that he has to pay to settle this bill? And how much interest does he actually end up paying for paying late? So what's the penalty here? So that's another way of saying that. What's the penalty they have? So first thing, my interest rate is actually not just going to be 0.22%, sorry, 0.22. And again, remember the percentage, we write it as a decimal when we actually carry out the calculations. We're not just going to write, the interest is 0.22. We have to divide that by 365. And again, the reason we divide by 365 is because there are 365 days in a year. So we're not getting paid, you're not paying 22% every single day. That's insane. You divide that by 365 because there are 365 periods in the whole year. So again, when you're doing this on your calculator, I do not recommend that you find out what 0.22% is and then divide by 365 and then memorize that number, write that number down. No, do not do that, right? What I want you to do is just keep that number stored in your calculator. Don't delete it. Now, by the way, if you ever do see something like this, that just means that it's you're going to have to move the decimal to the left 4 times, which ends up giving you 0.0006027. And again, it's a much longer answer, but I'm going to leave it like that. And again, I ended up rounding the answer here for you, but I'm not rounding it on my calculator, right? So how many compounding periods do we have? Well, this is where we got to do a little more math. If there are 12 weeks in a year, if there are 12 weeks that it's overdue, and we know that there are 7 days in a year, right? Sorry, 7 days. Sorry, I'm getting tired here. 7 days in a week. Then we simply take the 12 weeks and we multiply by the 7 days. Again, that should hopefully make sense, right? Grab a calculator if you're not, grab a calendar if you're not sure, right? 12 weeks. You know that there's 7 days in 1 week. So that means the total amount here, the total number of days would be 84 days. So there's 84 compounding periods or days. So this interest is accumulated or compounded a total of 84 times. So that means that I'm in my formula, I'm going to have to take A, which is what I'm trying to solve for, the total amount, or the total amount in your account, is the principal, basically how much did you invest, your investment, how much did you put into the account, multiplied by 1 plus 0.22 divided by 365 to the power of 84. Okay, so I take my initial amount that I put into the account, which is $2,500, and I multiply this by 1 plus 0.22 divided by 365, all raised to the power of 84. So again, I definitely need a calculator for this. So I mentioned to some of you that your calculator, you got to be quick with it and being able to do all these calculations all at once, right? So again, make sure you're comfortable with using your calculator there. I personally am not a fan of the computer ones. I prefer using my own calculator, my physical one here, but because I'm showing you this lesson, I'm just using the one on the computer, but I prefer to use my own anyways. So I'm going to raise this to the power of 84. And again, you always do powers first. And then I multiply this by 2,500, and I end up getting $2,629.79. So that means that Joe will need to pay $2,629.79 to settle the bill. So what does that mean, big picture? So in the end, because Joe was late, not only does he have to pay the $2,500 back, because obviously he has to pay that back, but on top of that, now he has to pay $2,629.79 total, right? But that doesn't mean that this is the total interest amount. That would be a little crazy. But it does mean that he's still paying quite a bit for interest rate. So for the interest that he's paying, it's still quite a bit because we take the $2,629 that he had to pay minus the $2,500 that he initially borrowed from the bank, from the credit card company. So that means that in total, he is actually paying $129.75 just on the late payment, on the late penalty. So $129.79 just for a late penalty. That's a lot. That's a lot of money if you think about that. $129.79. That kind of sucks to have to pay that just because you were late on your bill, right? But it is what it is, right? And that's what happens when you, like I said, if you are not responsible with the credit cards and you don't pay it on time, you'll have to pay interest on that. So that's why I mentioned from the very beginning in lesson one, credit cards are not necessarily bad. They actually do help you build credit, but you need to be responsible with them, right? And you need to pay them off on time. So let's look at another example, a little bit different. Again, you will definitely have a question like this. It's a multiple choice, or sorry, not multiple choice, fill in the blank question, where you have to calculate this. So you're going to be working backwards to figure out what the interest rate is. So Richard has cashed in a savings bonds that has a value of $4,500. So that's how much you end up getting for this. So savings bonds, I don't know if you know what that is, but it's essentially it's almost like an investment. It's kind of like stocks, right? You invest in a certain company or a more, not necessarily company, it's more kind of more secure investment here. And you put in the money, you say, hey, listen, I want to get this amount. Sorry, I'm putting in this amount in the hopes that at the end I will get $6,000. That's what we're saying in this example, right? We're putting in this amount, you're purchasing this amount, and in the end, after 10 years, you end up getting $6,000 from the savings bond. So what we need to figure out is what is the annual interest rate of the bond compounded monthly. So what was the actual annual interest rate for this? So to find the annual interest rate, so we're going to take $6,000, right? And we know that the $6,000 is the amount that I want to earn. So that's going to be my A value. My P value is 4,500. My number of compounding periods. So this is where you have to do a little bit more math. So we are investing this for 10 years. So doing some math here, if you're investing this for 10 years, and we know that and it's compounded monthly, and we know that there's 12 months in a year, then that means that I have a total of 120 compounding periods, right? And that's going to be my N value. My N value is going to be 120 because I have 120 months or 120 compounding periods. So I take the number of years times 12 months in a year, and I get 120 months. Okay, so that means that in my formula, I'm going to have A is equal to P times 1 plus I divided by 12 to the power of N. So I sub in all the values that I have here. So I'm simply going to be working backwards to figure out what I is. I sub in $6,000 into my A value because that's what I'm going to earn, right, in the future. And we'll talk a little bit more about what I mean by future. I'm going to invest $4,500 into my account, which is my P value. And I'm going to take my interest rate and divide by 12 and then add 1. And of course, I raise that all to the power of 120. Okay. Again, when you're doing this on a calculator, you would think that you would add the 1 and then add the interest rate. Don't make that mistake, right? You want to figure out, you want to do, again, this just goes back to BEDMAS. You want to divide first and then you want to add. Okay. So be careful with the order there. So grab a calculator. Okay. Make sure that you're comfortable with this. Actually, sorry, I've totally forgot. In this case, our interest rate is not given to us. So if we did have the interest rate, sorry, I forgot this was a bit of a different question. In this case, we're actually solving for the interest rate. But if you did know the interest rate, of course, just like the other examples, you want to divide first and then add 1, then raise it to the exponent and then multiply, right? So you have to kind of go in order. So divide first. Again, this is just BEDMAS, right? Brackets first, and then you do division within it. Then you add the 1, raise it to the exponent 120, and then multiply. Okay, but this is a little bit of a different question because we're actually solving for I. So this is basically an algebraic question. So we want to isolate for I. So what do we do first? Well, I want to try to get rid of as many of the numbers on the right-hand side. I want to bring it over to the other side so I can isolate for I. Well, the first number I can get rid of is the 4,500. And I know I can do that by simply dividing because the opposite of multiplying is to divide. Again, we're basically doing BEDMAS backwards, right? So we want to be dividing by 4,500 first so I can isolate for my for the power here. So then this ends up giving me, when I do this, I end up getting, actually I'll go step by step here because I don't want to rush this too much. Let's go over here. So grab a calculator, 6,000 divided by 4,500. You actually end up getting 1.333, which is actually 1 1/3, but I can write it. I personally don't like to write 1.133 because then, sorry, 1.333 because then students tend to round that off, and I don't want you to round anything off here. So I'm going to say 1 1/3, okay? So this is equal to 1 plus the interest rate divided by 12 to the power of 120. So what's my next step here? Well, my next step is to try to get rid of that exponent there. So I do that by doing the opposite of raising it to a power. I take the root. Do you remember in unit 4 when we learned about roots, we learned about exponent laws, how if I want to eliminate a power, I can basically, so if I had something like a to the power of 120 and is equal to, I don't know, I'm making this up, 4, and I wanted to get a to the power of 1, I just wanted to have an exponent 1 there, I can actually raise this to the power of 1 over 120, and then that means I have to raise this to the power of 1 over 120, and luckily, we know that a power with a fractional exponent can be rewritten as a root. So I can actually rewrite that as the 120th root of 4. So that's essentially what I'm doing here, right? It's the same idea. I'm basically going to take the 120th root on both sides of the equation so I can isolate for my base there. So I'm going to take the 120th root of 1/3. So when I do that, I'm going to erase this so it's a little neater now. I'm going to be taking the 120th root on both sides. And again, I can write 6,000 divided by 4,000, sorry, 6,000 divided by 4,500, or I can rewrite this as 1 1/3. It really depends on you. So I'm going to be taking the 120th root on both sides. And when I do that, I end up with just a base on its own, no exponent, because technically it's raised to the power of 1, but anything raised to the power of 1 is just itself. And now I'm just taking the 120th root of 6,000 divided by 4,500. So again, grab your calculator and let's figure out what the 120th root is here. So the 120th root of 600, so I first take 6,000, sorry, divided by 4,500. And now I'm going to take the 120th root of this. Now the root button here, we have a square root button, but we don't really have 120th root button, right? And that kind of makes sense because it's very specific. So what you want to do is you want to press this second button. It might be a little different on your calculator. It might be shift, second function. I don't know what else it can go by, but those are the most common scenarios. You're going to be looking for this button right here that says the square root of x, sorry, the y root of x. So you click on that, and what it does is it allows you to take any root. It doesn't have to be the second root, the third root, the fourth root, any root here. And then I simply press 120 because I'm taking the 120th root of that. And again, there's lots of online calculators for this as well, right? You could always use that as well. And you end up getting 1.02400 blah, 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 blah. Okay. Now, because this is actually a percentage, and actually, I think I made a mistake here because I got a different answer here. Unless I made a mistake here. Let me just see. I think I did make a mistake. Sorry. So I end up getting 1.024. Okay, I'm just gonna go with this answer. I think this is actually correct. I think I might have made a typo there, and I'll definitely fix that up. So 120th root. Let me just double check again. Yes. Okay. So I think that was actually wrong there. So what I'm going to do now is I'm going to simply subtract this, subtract off 1 here. Oh, I think I know what is wrong here. I think so. Okay. So we're gonna subtract off 1 in our next step. So I'm going to be subtracting off. No, I actually know what I'm missing here. I think it's because I ended up multiplying by 12. Just keep going with this. This is all good. So I'm going to take that answer that I had, which was, and again, I wouldn't even bother storing it on writing it all down, I would just make sure that you're continuing this on your calculator. So I take that answer that I had there, and of course, what I'm going to do now is subtract 1 on both sides so I can isolate for I, right? I want to isolate for I, so I subtract 1 on both sides. And then I'm going to take that answer, and I'm not done yet. I'm going to take that answer and I'm going to multiply by 12. And why am I multiplying by 12? So the reason I'm going to multiply by 12 is because this answer that I end up getting, let me just show you here. So the answer that I end up getting, let me just scroll down here, was, again, when I subtract off the 1 on both sides, I end up with 0.00240023. I don't even want to round too much, but I just want to show you, again, I just want to show you what's happening here, right? We end up with 1.002400 blah, 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 is equal to I over 12. But if I want to isolate for I on its own, because remember, the question was asking me, what is the annual interest rate compounded quarterly? So I still want to know, what is the actual interest rate for the whole year, right? Generally speaking, we always want to find out what the interest rate is for the whole year, even if it's compounded differently, right? So I really am just asking you to isolate for I. Now, I will make the your test question a little bit easier. I will make it so that it's not compounded monthly or quarterly. It's just going to be compounded annually. So you won't have to do this extra step. So I'm going to make it a little bit easier. You won't have this extra step here. So you're going to multiply by 12 on both sides so that you can isolate for I on its own. So when you take 12 and you multiply by 1.00240023, blah, 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 I end up getting, so again, multiply this answer, and again, I didn't delete it. I just multiplied by 4. I end up getting 0.0288, and so on. And I'm just going to round this to, again, this one is a percentage. So percentages, I don't necessarily have one specific way to round it. So I'm just going to multiply by 12. I end up getting this answer here, which is a decimal. But normally when we write interest rates, we like to write them as a percent, as a final. So when we write the final answer, we normally want to write it as a percentage. So to write this as a percent, remember, if you're going from decimal to percentage, you multiply by 100. So you get 2.88% if you round it to 2 decimal places. So it's a compounded, it's an annual interest rate of 2.88% compounded monthly. So we still have to write compounded monthly because, again, it still was compounded monthly, but the question specifically asked us for the annual interest rate, and that's what it was there. So I hope that made sense. And that was basically it. There's the homework there, and best of luck with all the questions. All right, see ya.